Today we're going to dive into one of the most intriguing and mind-bending puzzles in philosophy and logic, the liar paradox. Imagine this. Someone says, "I am lying." Is that statement true or false? Seems simple, right? But trust me, it's a lot more complicated than it looks. Let's unravel this paradox together. So, what exactly is the liar paradox? At its core, it's a statement that declares itself to be false. The classic version is the sentence, "This statement is false." If the statement is true, then what it says must hold. Hence, it's false. But if it's false, then what it says is not true. Hence, it's true. Confused yet? That's the paradox. This paradox has fascinated philosophers and logicians for thousands of years. It dates back to ancient Greece, attributed to a philosopher named Epimenides, who was a Cretan. He supposedly said, "All Cretans are liars." If he's telling the truth, then as a Cretan, he must be lying. But if he's lying, then not all Cretans are liars, which means he could be telling the truth. And around we go. Let's look at some everyday examples to see why this paradox is more than just an academic curiosity. Think about a scenario where someone says, "Everything I say is a lie." If we believe them, then this statement itself must be a lie, meaning sometimes they tell the truth. But if the statement is true, then they are lying, which means the statement cannot be true. It's a logical loop with no clear resolution. Now, you might wonder, why does this matter? It's just a brain teaser, right? Well, the liar paradox has profound implications for logic, mathematics, and even computer science. In the early 20th century, mathematician Kurt Gödel used a similar paradox to demonstrate his famous incompleteness theorems. These theorems show that in any consistent mathematical system, there are statements that are true but cannot be proven within the system. This was a groundbreaking discovery, changing our understanding of mathematics and logic. In computer science, the liar paradox highlights the limitations of formal systems. When designing algorithms and programming languages, developers must ensure that they avoid self-referential loops that could cause the system to crash or behave unpredictably. The paradox shows us the importance of carefully defining rules and boundaries to prevent logical contradictions. But let's bring it back to a more relatable context. Think about social interactions and trust. If someone frequently says contradictory things, it becomes hard to know when to believe them. The liar paradox can serve as a metaphor for the complexities of communication and trust in human relationships. It reminds us that words can be tricky and that we need to be careful about the logical consistency of our statements. So, how do we deal with the liar paradox? Philosophers and logicians have proposed various solutions over the years. One approach is to declare such statements meaningless because they don't fit neatly into our true-false dichotomy. Another approach, called paraconsistent logic, allows for statements to be both true and false simultaneously, though this challenges our traditional understanding of logic. Another interesting perspective comes from Alfred Tarski, a logician who developed a theory of truth. Tarski suggested that statements about truth should be made in a higher-level language than the statements they refer to, thus avoiding self-reference. This way, we can talk about the truth of a statement without creating a paradox. In practical terms, dealing with paradoxes like this involves recognizing the limitations of our language and logic systems. It's about being aware that some statements can't be neatly classified as true or false, and that sometimes our attempts to categorize and simplify can lead to contradictions. To wrap it up, the liar paradox isn't just a quirky puzzle. It's a window into the complexities of language, logic, and even human nature. It challenges us to think deeply about truth, consistency, and the boundaries of our understanding. So next time you hear someone say, "I am lying," you'll know there's a lot more to that statement than meets the eye. Thanks for joining me on this mind-bending journey. If you enjoyed this video, give it a thumbs up and subscribe for more fascinating explorations into philosophy, logic, and beyond. Keep questioning, stay curious, and I'll see you in the next one.